In this video, I'll demonstrate the basic features of Google Colaboratory. It's not my goal here to show you absolutely everything it can do, because we are still just getting started. But you should know the basics so that you can start benefiting from this tool as soon as possible. To get started, let's open up a new notebook together. In your web browser, go ahead and navigate to colab.research.google.com, and then click on the New Notebook button. This will automatically create a new Google Colab document within your Google Drive. The document you see here is called a notebook. Google automatically gives the notebook a title of something like untitled some number.ipynb. The file extension .ipynb stands for IPython notebook. Now, that's not something you need to remember, but hopefully that makes the file extension mean something to you when you see it again in the future. Let's give our document an actual title. You can call yours whatever you like. I'm going to call mine intro notebook.ipynb. Next, we're going to focus on this middle section of the document. This is where all the magic happens. A notebook is made up of a bunch of what are called cells. And there are two types of cells. There are text cells and code cells. When you hear the word cell, I just want you to think section, right? This document is going to have some code sections and some text sections. In the code cells, we'll write Python code to analyze and clean our data, fit machine learning models, all that fun stuff. Learning what to write in the code cells and the process for properly preparing and modeling our data is the bulk of what we're going to be learning in future lessons and courses. Whenever you open a new notebook, it will always start off with one code cell already created within it. Go ahead and click on it and type print hi, something like that, something simple. Let's run the code cell by clicking on the play button on the left-hand side. Now that we've run some Python code, we can see that a code cell itself is made up of two sections, an input section and an output section. The input section is where we write our code. The output section is the area beneath the code where we see the word hi displayed. Our code won't always generate an output, but often will intentionally cause things to be shown here to make sure that our code has run successfully and that our program is doing what it should be. Let's add a new text cell to our document. You can add a new cell either by hovering over the section immediately before/after a cell, or by using the add code or add text buttons on the left-hand side just below the main menu. If you accidentally add more cells than you want, or have them in the wrong order, you can delete any unwanted cells or rearrange the order of the cells using the buttons on the top right of any cell. Let's make sure that our text cell comes before the code cell, and then we'll add some content to it. In text cells, we document our work. We'll often be sharing our notebooks with others, so it's important that we explain what we're doing so that others can follow along. Text cells operate using a markup language called Markdown. Markdown is a system for controlling the structure and formatting of documents. And it's really nice because all it takes is the addition of a few symbols to make our document look professional. We write Markdown as plain text, regular text, but then the symbols that we add to it get interpreted by the computer and rendered into the version that readers end up interacting with. To show you what I mean, let's edit a text cell. Now, let's go over some of the basics of Markdown. I'll link to a full Markdown cheat sheet below the video. As you type in a code cell, Colab will automatically generate a preview of the rendered version of your Markdown here on the right. You'll see that on the left side, I'm just typing plain old text. But if I add a £, for example, at the beginning of the line, some of you may know this symbol as a hashtag, then our text will be transformed into a large heading. The more £signs we add, the smaller the heading will be. If I want just a regular paragraph of text, then I don't add any £signs at the front of it. We can also easily italicize and bold words. A single set of asterisks or underscores will cause the words to be italics, and a double set of asterisks or underscores will cause the text to have a bolded font. We can create a bulleted list by beginning each new line with a dash, or we can create an ordered list by starting each new line with a number and a period. We can easily turn any text into a link by wrapping the text that we want to serve as the active link in square brackets And then immediately following the closing square bracket, we'll put a pair of parentheses. Inside of the parentheses, we put the URL that we want to link to. We can even insert an image in almost the same way. The biggest difference is that we put an exclamation point just before the opening square bracket. And in this instance, the text that we put inside of the square brackets will become the quote-unquote alt text of the image. Alt text is important so that individuals who have impaired vision and also search engines can get an idea of what is in an image without actually viewing it. So we want the alt text to describe what's in the image. In order for an image to show, we need a link to the image. This can usually be found by first finding the image that you want to embed shown in a web page, and then you can right-click on it and say Copy Image Address, or you can click on the Open Image in New Tab option and then just copy the URL from the browser's URL bar. If we drop the link to the image inside of the parentheses, then the image will appear. The first time I did this, I was shocked by how easy it was to embed an image in Markdown. If we want to format something as code, we will wrap it in tick marks. The tick mark symbol is found on your keyboard just to the left of the number 1. It shares a key with the tilde symbol, that kind of wavy line. If we want to showcase a large block of code, then we can do the same thing, but using a set of triple tick marks instead. We can also add code syntax highlighting by writing the name of the programming language represented in the code block immediately after the opening trio of tick marks. Now, there's a lot more to Markdown as well. There's also block quotes, horizontal rules, and tables. Tables require a bit of typing. I've got one prepared here that I'll copy and paste into the document instead of making you watch me type it all out. If you want to add tables like this, I recommend using a Markdown table generator tool so that you don't have to type out all of this manually. I'll link to one that I like below the video. And that's the basics of using Markdown within text cells. Text cells do have a few other tricks up their sleeves, but what I've shown here should be more than enough to get you started. Now that we've covered a lot of the most important aspects of text cells, I've got a few more features of notebooks that I want to show you. Let's explore them by doing something fun in this notebook. Now, just a heads up, I'm going to write some code in this next demonstration, and I just want to emphasize that I do not expect you to fully understand or follow along with the code that I'm about to write. What I want you to focus on is what our notebook is doing. In the previous video, you'll remember that I talked about how Google Colab is a cloud-based notebook editor because it talks to and runs all of our code not on our own computers, but instead on a computer at a Google data center somewhere. You'll also recall that part of what's so great about Google Colab is that it comes with all kinds of pre-installed Python packages that are ready for us to use out of the box so that you don't have to worry about any of the setup. Well, I want to use one of these pre-installed Python packages to give you a very small taste of what it's like to work with actual data in a notebook, while emphasizing some of the most important features of Google Colab. All right, I'm going to remove all of this stuff from the text cell we just added, and just add a header that says, making a graph with Seymour, because that's what we're going to end up doing together. Let's also delete the print statement from our code cell and replace it with the following: exclamation point, pip, PIP, and then freeze. When we run the cell, this line of code will cause all of the tools that Google Colab has and their version numbers to be displayed in the output section of the code cell. Just take a look at this list. There's all kinds of stuff here. In particular, there are some familiar names like NumPy, Pandas, Matplotlib, scikit-learn, TensorFlow, and many others, right? The gang is all here, as they say. By the way, you see how the output section of this code cell is really long? If I find that the output section of the code cell is so big that it's in my way while I'm working, I can click on the 3-dot icon, kind of vertical triple dots, on the far right of the code cell and then select Clear Output from the drop-down menu. And that will remove the output section of the code cell. If I want to get the output back, I'll need to run the code cell again, which brings me to something else. Before we start using one of these juicy tools, I want to take this opportunity to point out that there are a lot of useful keyboard shortcuts that you can use to speed up your work in Google Colab. But for starters, there's one in particular that I want to draw your attention to. If I have a code cell selected and I hold Shift and then hit Enter, that will automatically run the code cell and move me down to the next cell below it. That way, you don't have to leave your keyboard and go to your mouse every time to click the play button. Just a helpful tip. If you use this keyboard shortcut while you have a text cell selected, it will close down the text cell editor and move you down to the next cell. So feel free to hold Shift and hit Enter a few times if you want to just run all the cells in your notebook starting at the top. Now, back to our list of tools that we saw in the output section here. You'll see in this list of available packages a tool called Seaborn. We're going to use this tool to load a dataset that comes along with Seaborn and make a colorful graph as a small demonstration here. The first step when working with a Python package is to import it into our notebook. Write import Seaborn as SNS, and then run the code cell. Now, Seaborn is ready for us to use. The as SNS part of this line of code means that we can refer to this tool as SNS in our code as an abbreviated form of its name. Now, the data set that I want to work with is called the Palmer Penguins dataset. It's one of my absolutely favorite so-called toy datasets, right? The Palmer Penguins dataset holds information about 3 different species of penguins. For each penguin listed in the dataset, we have the penguin's species, the island they were found on, some measurements of their bill and flippers, their weight, and the sex of the animal. Here, let's even include an image of the 3 penguin species in our first code cell, in our first text cell to liven up the notebook. Let's go ahead and load the dataset now in a new code cell below the first one by running the following line of code. df space equals space sns.load dataset, an underscore there, and then we'll pass in this penguins inside of quotation marks inside of the parentheses. Again, I don't expect you to understand fully what this line of code is doing, but just know that df here stands for data frame. A data frame is basically a fancy table that holds our data and helps us work with it. In the next code cell, go ahead and write df.head and then parentheses. df.head will display for us the first 5 rows of the dataset. This is one example of us causing something to be displayed in the output section of the code cell so that we can verify to ourselves that the dataset truly has been loaded and that everything looks to be in order. Very cool. I hope that this helps you get an idea of what the data looks like. Next, I want to make a fancy graph with this data called a pair plot, but we're going to pretend that I've forgotten how to do it. I want to show you a couple of ways that Google Colab can help jog our memory if we know that a tool exists but can't remember exactly how to write the code for it. And I want to emphasize that this is a common situation that you'll find yourself in. A lot of beginner data scientists get quickly overwhelmed by all the different tools that we use. New learners often make the mistake of trying to memorize everything and remember how exactly to use each tool that they've ever brushed up against. But there's just too much to be able to memorize it all. The things that are worth remembering, you will naturally memorize over time because you'll do them again and again. Even the most senior data scientists have to look things up constantly. It's a regular part of the job. So don't feel like a failure if you have to look something up. There are 3 different methods of looking up documentation within Google Colab that I want to make you aware of. Well, 2 are within Google Colab and 1 is external to Google Colab. You'll see what I mean. Let's say that from memory, I know that I want to make a pair plot. I at least know the name of that graph, and I want to do it using the Seaborn library. But that's all that I can really remember. A helpful tool that I can use is something called the help function. Type out help and parentheses, and then inside of the parentheses, put the name of whatever you want help with. In our case, we'll type sns.pairplot. This will pull up the official documentation for pairplot and display it in the output section of the code cell. Now, this documentation probably won't make a whole lot of sense to you right now. Don't worry about that. We'll get really good at reading documentation as time goes on. A second method that I like a little bit better than this is to type sns.pairplot, but then to just put a question mark at the end of it. This will pull up the same documentation, but we'll put it in this convenient sidebar. It's really up to you which of these 2 methods you prefer. Try both and see what you like best. I tend to like the sidebar because then the output section doesn't get in the way when I'm scrolling through my notebook. So Those are the first two methods. They're both really helpful. However, my favorite method of looking up documentation doesn't have to do with notebooks at all. I like to just Google for the thing that I'm trying to do. There will always be web pages that host the tool's official documentation out there made by the creators of the tool. There's also posts on a forum called Stack Overflow that might be helpful, or just blog posts and other tutorials out there that have been made by kind individuals. Getting good at Googling things when you get stuck or can't remember something is a really important skill to develop. It's part of what I talked about with, senior data scientists having to look things up constantly. We're Googling things really often. Before we actually go and Google this, I'm going to remove some of these other code cells from our notebook so that they're not in the way as we try and make this graph. I want it to be just really clear what we're doing. Now, if you want to refer back to these lines of code that I'm removing here, you can look them up in the video transcript found below this video. Now let's open a new browser tab and Google Seaborn Pairplot. Pairplot is one word here. And I'll show you why this is my preferred method for looking up documentation. Here we see the official Seaborn documentation for Pairplot. You'll notice that the text on the page here is pretty much exactly the same text that we saw using the help function and the question mark methods. But in my opinion, the text here has been formatted a little bit nicer and is easier to read. But that's not the best part. If we scroll to the bottom here, there are usually code examples of how to make this graph. These are really valuable to me, and they're typically not included when we use the help or the question mark method. From this documentation, I could learn that I should type sns.pairplot and then parentheses, and then put the name of the data frame inside of the parentheses. In our case, we've called our data frame df. Let's try that and run the code cell again with Shift-Enter here. It may take a second for the graph to be built. This is a little bit bigger than typical graph, so it might take a second for it to process all of our data points. There we go. We have made a graph. This graph shows scatter plots comparing the bill, flipper, and weight measurements of the different penguin species. And there's histograms along the diagonal that show the distribution of each of these different penguin characteristics. And what's great is it didn't really take a lot of code to make this somewhat complex visualization. Again, I don't expect you to fully wrap your head around what this is showing here. It was really just a demonstration. But if we revisit the documentation quickly, you might start to get an idea for what this documentation is trying to tell us. All of these parameters you see here in bold, like hue order, palette, vars, kind, etc., are other settings that we can use to control how our graph looks. Don't worry if that didn't jump out at you from the documentation here. Again, reading and understanding documentation is a skill that we're going to practice a lot. And this documentation will make a lot more sense when we've learned more about how to write code with Python. Let's try one out though. Let's add hue equals species to our pair plot. You can also see an example of that code at the bottom here. Let's try that one out and see how it changes what our graph looks like. Now, if you look closely at the Seaborn documentation, you'll notice that they're also using the Palmer penguins dataset in their code snippets at the bottom of the documentation, which is part of why I chose to use that dataset for our demonstration so that you can copy directly from docs and have the same results as we're getting in our notebook. I also want you to notice that this graph is displayed in the output section of our code cell. The ability to create graphs like this and for them to be displayed within the notebook immediately after the code that created them is another advantage of notebooks over other code writing tools. Sometimes when we write Python in other tools, the graphs will simply be exported as files and won't live alongside our code, which is good in some ways, inconvenient in some ways. I think it's really nice for notebooks to be able to tell this coherent story from top to bottom. And on top of that, graphs and visualizations can be effective communication tools if we use them wisely. And they also add a little bit of visual flair to our notebook. Next, I want to go over one of the biggest points of confusion for new learners when it comes to notebooks. Here in the top menu, you'll see a runtime button. And below that in the dropdown, there is a restart runtime option. Go ahead and click on it. This little warning pops up here. Go ahead and read through it, but we're basically just going to say yes. We're sure that we want to restart the runtime. When we do that, you'll notice that in the top right of the notebook, it's going to show itself rebooting more or less, and that the little numbers that used to be next to every code cell have disappeared, but that none of our code cells or text cells have been affected. Even the graph is still there. If none of our code cells were affected, what was the point of Google Colab warning us that things were going to get deleted? If we make the pop-up appear again, let's go back up here to the menu. If we read it more closely, we'll see that it said that runtime state, including all local variables, will be lost. Well, what is this so-called runtime state? Also sometimes referred to as hidden state. As we write code, we'll often do things both intentionally and unintentionally that will cause things to be stored within our notebook's internal memory. That's essentially what this hidden state is. Let's think about it. Rerun the code cells up to the point where we loaded the dataset. Then I want you to click on this X surrounded by curly braces button in the left-hand sidebar. This variable inspector panel, as it's called, tries to help us see our notebook's internal storage. When I loaded the dataset, this equal sign told the dataset to store itself within my notebook under the name df. This stored the Penguins dataset in a way that it could be retrieved from the notebook's memory whenever we use the variable df. And we can see the df variable listed in the left-hand sidebar. This is why we continued to use the variable df in the next code cell where we ran df.head. We were essentially saying there, hey, notebook, pull up that dataset from your memory and show me its first 5 rows, which is what .head does. Let's try something else. Let's restart the runtime yet again, but this time skip down and immediately try and run the df.head code cell and see what happens. This time, we've got an error message saying that name df is not defined. When we restarted the runtime, we didn't change any of the cells in our notebook, but we did wipe out our notebook's hidden state. We can't look at the first 5 rows of the notebook because the dataset has been removed from our notebook's internal memory. The little numbers on the side of each code cell were trying to tell me that I had skipped some of the potentially important code cells. And that's one way I might have recognized my mistake. These numbers on the left-hand side of each code cell are very important. They're called the execution count, and they indicate to us the order in which the cells were run. If I had looked here first, I would have seen that I hadn't yet run the code cell where the dataset would be loaded, and I had skipped some steps. Which brings me to a really important point that I want to get to. In a perfect world, notebooks would be run from top to bottom, executing each cell exactly one time. However, when we're drafting the document and working on it, that's usually not how we interact with the notebook. We're usually jumping around and editing things and trying things out. And sometimes we run code cells out of order. And when we do that, funky things can start to happen to our notebook's internal storage. Things can get mixed up. I want you to be aware of this potential pitfall because sooner or later, as you're working with a notebook, weird things are going to start to happen as a side effect of the order that the code cells have been run in. And when that happens, here's what I want you to do. First, double check the numbers on the left-hand side of each code cell to make sure that you haven't accidentally forgotten to run a cell or have run the cells out of order. Sometimes even running the same cell multiple times can cause problems. Secondly, if these funky problems persist, restart the runtime and then rerun the code cells from top to bottom. Doing that will usually iron out any weird behavior. This is the notebook equivalent of the common IT advice to turn it off and then back on again. When you're done with your work and ready to share your notebook with others, it is a best practice to restart the runtime and then run each of the cells in order just to make sure that everything's working properly. Or you can use the restart and run all option that you'll see in the drop-down menu here. All right, I realized that all that might have been a little bit confusing without some more firsthand experience with notebooks. So for now, all I want you to remember is just keep an eye on the execution counts, make sure those numbers make sense, and if weird things start happening, don't be afraid to restart the runtime. It will delete the notebook's internal memory, but it won't delete your work. Because Google Colab is a cloud-based notebook editor, that means that a Google Data Center computer is serving as the file system for our notebook. So if we want our notebook to have access to files on our local machines, we'll need to do a little bit of extra work and upload any necessary files from our local computer to this specific Colab notebook. Again, in the left-hand sidebar, you'll see a new icon. This is the folder icon we're going to click on here. When you click on this icon, it will open up what's called the Files pane, where we can upload files that we want our notebook to have access to. go ahead and click on the upload button. It's this little piece of paper looking thing with the upwards arrow. Use that to select a file from your local computer. Files that you upload will only be available while the notebook's runtime is active. So if you happen to close this tab in your browser or step away from your computer for a long period of time, your notebook's runtime might shut down. When that happens, you might need to re-upload any of the files that you want to be using. After you've uploaded a file, you might need to click on the refresh button that's just to the right of the upload button in order for the file name to show up in the sidebar. You should be able to see any of the files you've uploaded and that you want to work with listed here in this panel. We could have almost as easily used this files pane to upload a CSV file of the Palmer Penguins dataset and then loaded the CSV to a data frame in a code cell, but I don't want to distract you any more than I have to with foreign code during this lesson. I mostly just want to make you aware that the files pane can be used to upload local files should you need to do so. One of the big benefits of working in Google Colab is that because this document lives in our Google Drive, we can share it with others just like we would any other Google Drive document. In the top right corner, click on the Share button, and you'll see that we have the option to share this notebook with specific individuals by adding their email address. Or we can also create a shareable link to the notebook. If you're ever stuck on something and you need to ask for help, it's a good idea to put the code that you're working on in a notebook in a way that reproduces the problem you're experiencing, and then share that notebook with whoever's helping you. That way they can easily see your code and review what you've done and then give you any necessary pointers. If you're using the share link, don't forget to change the access settings to anyone with the link can view, or else the person you're sharing it with won't be able to have the permissions to see the notebook when they click on the link. And there you have it. That's an overview of the most important Google Colab features for beginner data scientists. The most important skill set that I hope you start emphasizing in yourself as a result of this video is getting good at looking things up and using references to refresh your memory when you forget something. And don't beat yourself up about it. Everyone looks stuff up all the time. This is part of why you having familiarity with Google Colab right from the get-go is so important. I hope that you will use this tool not only to do your core data science work, but also to create references and cheat sheets for yourself. If there's something that you find yourself looking up often, make a notebook about it, explaining to yourself how that tool works. Not only will this help you learn more thoroughly whatever it is you keep on forgetting, but having those additional references will help you be productive and efficient in your work.